and we're going to start Breakout 1 with George Maynard.
All right, so the first day breakout groups, these are going to be really boring slides. It's just the question up at the top and then bullets underneath. I thought Linus was going to do a dance, but he canned that idea, so yes. So the first question we had to talk about was what types of data are of interest to you? And the response from the members of the industry who are here is that it really depends on your fishery and fishing location. So for the guys in Cape Cod Bay, DO was certainly of interest. Given the discussions around salinity, a lot of the lobstermen in the room were interested in that. In our group, we went kind of down a weird rabbit hole about subsurface tidal currents, where both fishermen expressed a feeling that the strength of these currents had increased over time. And they said it would be applicable to both fixed and mobile gear. For fixed gear, being able to see after some big currents where their gear might have moved to if things got shifted around. And for mobile gear, you have a good idea of what's going on the surface, but when you drop the net or the dredge, you may not know what's going on underneath. So having some better information about what's happening with water movement below the surface. There was also concern about wind farms and changing current dynamics around those, and how that might impact settlement of juvenile lobsters, juvenile scallops. So the idea was also brought up of using those wind farms as sort of stationary monitoring platforms for a lot of that type of information. Some fishermen said that they're not really sure what they need to see until they see some measurements that trigger an idea in their head. So more interactions with the scientific community, more easy to understand oceanography, like Glenn presented yesterday. Whatever data it needs to be, they want it to be accessible quickly and easily. Some folks mentioned non-point source pollution, such as pH issues, nutrient loading, and DO closer into shore, and how that may impact particularly nursery habitats for some species. Weather stations came up. Jim Ford had one of those on his vessel, and I know that's been talked about in sort of getting better, finer spatial resolution in the offshore forecasts. Yes, then that brings us to what are the most effective ways to return the data. So obviously there's privacy concerns around some of this data. Some folks mentioned binning their data into binning everyone's data into 10-minute squares and being able to see only their own data at sort of a fine resolution. Having color-coded sort of bins of data that are easy to interpret rather than providing numeric values that may not have any context, particularly if they're displayed in metric units. There was a thought about delaying delivery of environmental data to the broader fleet and allowing captains to access data right away, their own data right away, and then share it out later, so that they were able to benefit from their data in real time, but everybody else would kind of have to put the pieces together a little while later. There was a lot of talk about some apps that we had never heard of, Time Zero and OLEX, and maybe thinking about ways to tie the sensors back into those apps that are already being used, to hardware that's already being used in the wheelhouse that the fishermen are comfortable with. So that way it's one less system for them to learn, one less widget for them to have on board, one less thing to break. Getting some seasonal overviews, so the messaging that Linus had talked about, where you get a push notification or email or video rather than having to go hunt the data down in a portal. And the ability to toggle back and forth between, that's cut off, but between tows. So being able to see not just what's happening right now, but oh, I've been thinking of that, 3 toes back, that was a lot better than this one, what changed? So being able to toggle back easily. When we talked about concerns that would inhibit fishers from participating in the programs, there was some discussion of how the data are being processed inside the black box, right? There's nobody wants to feel like what they're collecting and then what they're actually seeing, has been manipulated in some way. So sort of providing to the fishermen up front, like these are the types, here's what the raw data would look like coming out of your sensor. And here's what we're doing to kind of clean it up and do some onboard QA/QC before we present it back to you. And here's why that's necessary. Providing more transparency about data processing. There were concerns about the accessibility of landings data and the ability to tie environmental data back to landings sort of more broadly throughout the fleet. Having their data used against them, particularly by environmental NGOs. Graying of the fleet, it's challenging for young people to get into fisheries, and those who do have a lot of work on their plate, and so it's harder to get them to volunteer in programs like this, or like any of the programs we've talked about here, unless we make it just very, very easy and low maintenance for them. Some need for incentives, paying them money or certifications or other skills that they may want. Trust building takes time and often needs to overcome sort of historical barriers. And then getting the buy-in of at all levels within the fleet. So some fleets, some vessels are owner-operator, so there's one person to deal with. On other vessels, if you're dealing with a more hierarchical fleet, there could be a fleet manager who's really gung-ho about something, and captains who just don't care, or crew who just don't care. And so, making sure to take the time to understand sort of the structure of the fishing companies. We discussed barriers from a scientific perspective to incorporating data. Some of those were, wanting to be able to aggregate data and match catch data, which, it's kind of goes, puts us on not so good trajectory given the concerns from the industry. QA/QC processes can be time intensive and labor intensive, and there's a need for support for those, especially for biogeochemical data. There's limited Wi-Fi and mobile cell network hotspots at the docks to offload data, so that getting the data back to the scientists can be challenging. Often requires going to the docks with a flash drive. Data portals, there's a feeling from some folks that it's a lot of effort to create a data portal, and if they're not being used, then that's a lot of wasted effort. So how can we make those more user friendly? There are concerns about sensor calibration and accuracy, and making sure that the metadata associated with particular sensors is made available along with the environmental data. There's also, we discussed integrating with other scientific efforts to sort of ground truth what's happening. So if there is a ventless trap survey going on, Tracy talked about, making sure that she collects some water samples with other instrumentation while she's out, so she can compare that back to what's being collected by the study fleet. We asked if fishermen would be willing to provide feedback for online portals, and got some feedback right away without having portals up. Fishermen want the ability to modify plots so they can plot what they're interested in. They don't want to just see temperature, just see depth. Maybe they're interested about the relationship or interaction between multiple factors, and they want to be able to plot those up on their own. They want to be able to view their data that they've collected on their vessels at a high resolution, but they're also interested in seeing what other folks are collecting at more of an aggregated bin level. There was an interest expressed in being able to access these portals in the wheelhouse particularly during steams, when they're close in and have service, and when there's not a whole lot else to do. And then also the ability to access them at home during the off season. We as scientists and as data providers need to be able to present multiple options for what's available to fishermen. Often, they're not necessarily web developers in their spare time, so they need to have an understanding of what the potential options are as far as data visualizations. So if we can present the same data multiple ways and show, okay, which one of these options do you like the best, rather than giving them an option and saying, is this good? That would go a long way. And finally, some ability to tag their own data to sort of validate some of their own mental models. So on board, could you color code a particular day or a particular tow as being good, and not have that data go anywhere else? Just have that stored, locally on your vessel that you could take a look at, rather than putting it up into an online portal. And I think that is all we had. So if people want to ask questions or discuss, that'd be great. Oh, sorry, we should wait for mics. This is excellent work. Are these slides available? Can you make them?
Yes.
Yes, great.
Yes,
we will definitely be doing that.
The question is yes. The question is, can these slides be made available?
Yes, the slides will absolutely be made available.
I'm particularly interested in getting data from sensors back to the people who need it.
Yep.
And one of the things that I'd like to do some follow-up conversations on are about using buoys and other permanent objects out there as what I call infrastructure. So places not just to put sensors, but to put part of the communications networks required to push data access out as far as we can. And in particular, the wind farms provide a tremendous opportunity in terms of being able to endure very bad weather conditions and having unlimited power and all those sorts of things. So if anybody wants to talk about buoys, wind farms, and things like that as infrastructure, I'd love to have that follow-up conversation. Thank you.
That's an excellent segue, because I was kind of curious about the wind farms, and I would open this question up to anybody here. Has anybody engaged BOEM or the wind folks about trying to install sensors on the wind farms or having access? Because I imagine that they already have data planned for that. Just kind of curious, because it's coming fast.
Thank you. I think Jake has quite a bit input down there.
Yeah, I've had a few discussions with people in the industry, and it's a big and heterogeneous industry, so there are varied opinions. There are some folks who think that the turbines are very logical platforms for sensors, that they're going to be in place for decades, and therefore you can build nice long-term time series. Others who are very wary about bolting stuff on their expensive pieces of equipment and stress that if we want to do that, it needs to be planned early. It needs to be factored into the manufacturing stage because you have issues with leakage. There's other, I think, practical concerns about operations. If stuff that's going to be on turbines is most likely to be run by the wind farms themselves, they're not going to want many. At Syracuse, we work with Hui and Yukon and UMaine and others to do the field operations, and they're probably not going to want outsiders messing with their stuff. I know I've talked to some folks in the fishing industry who are concerned about data quality, if the information is coming directly from the energy industry as opposed to being operated and run through some third party. There is an increasing interest I'm seeing from within the energy companies, though. Many are already deploying their own mid-ocean buoys, but we've been talking to them about doing that more collaboratively, kind of coordinating a buoy network at the scale of the wind energy area. cost sharing on its operations, having that run through a third party external to the industry, and having the data be fully publicly available. So that might be a long-winded way of saying I personally have a lean toward buoy-based infrastructure, but I don't think it needs to be an either or. I just think there are going to be, buoys have the advantages of being able to be outfitted with more sensors. You can put them exactly where you want them. You can move them around if they were in the wrong place. And I think you have some operational, logistical, and funding advantages that you won't have by putting stuff on turbines. But I think turbines will have important advantages. All right, the last thing I'll say is talking to our oceanographic modeling team at SMAST for improving models of surface currents in particular. There's a lot that happens at the turbine. And they're very interested in direct measurements kind of at those locations where the water first meets the piling and starts to deflect in different ways. So I think it's going to be a mix.
Thank you. Go ahead, Dave.
We have been, the Mass Lobstermen's have been directly involved in all of the pre-studies. We've done all kinds of studies primarily on our industry, the lobsters, but it's gone with everything else, with the wind farms. And it would, right now, I feel the same way. It would be most likely a no on attaching anything. You're talking about something within the water column, not above it. Above it is theirs. They'll put any arrays they want up there to determine whatever they've got to have, and you want it below the surface, and it's going to be rather unlikely that they're going to allow any of that. These structures are not just the tower. There's also going to be a support system around them, which minimizes what you can do on that right there, which goes back to, are you going to be able to put some type of an array with floats? No, they won't allow that near it either. And now we're going to, the biggest worry about commercial fishing within a wind farm, having looked at for years and years the European models and everything, is, are they going to become even more restricted around it, in giving areas around it that are a no access zone? Never mind allowing a vessel to come up to it to try to detach some type of scientific equipment. I think it's a long way off, but I got a feeling that it isn't going to happen, not easily.
Other questions?
I just wanted to make one brief comment, but something that I think, everyone should be also considering is that for some of these buoys, either on the surface or below, they require end lines just as much. So you have to consider about that now too, and the consideration of not having any vertical lines in the water. So I know, talking to a few people this meeting, they're like, oh, we could just put buoys out and it'll be okay. But that's now a challenge just for scientists as it is fishermen.
Just wanted to flag that online, there was a message from Owen in the chat that there is literature to suggest that ocean circulation patterns change around wind farms. So,
Jake and others who know more about this, I recently had a conversation with somebody from the wind industry, and I apologize for forgetting the terminology, but in addition to the turbines, which there are many, many of, I think there's some kind of node infrastructure that's paced more coarsely, that I wonder if it might be possible to observe at those towers where there won't be turbines. They're kind of a power and comms hub. Has anybody approached that? No? Okay. It is, right, but I mean, the other thing that could offer, if we could partner with them, is power and communications for demanding sensing, beyond the basic stuff that you can now put on a buoy.
It's in the works. I mean, we haven't abandoned it. We'd like to have more research and more information from the area how we get it within the area is important. Yeah, we've got to watch out for vertical lines during a certain percentage of the year. Where our biggest concern is, can the commercial fleet continue to work within this array? That's our whole fight. Can we get in within it? Are there going to be limitations, restrictions? What's going to happen now if you're going to try to access it with any type of instrumentation? That all falls on whether or not they want to allow you to even get near them. Right now, no.
So,
I mean,
well,
we know that.
My understanding was that the regulations, the U.S. Coast Guard regulations that currently apply for oil and gas industry are being revised to include renewable energy and wind farms, and those basically include no restrictions because that's what Coast Guard regulation has.
You're probably right, but we've faced it in other areas. I'll give you the North Shore LNG pipeline and the access outside of that. There is a no-go zone around it. You can't get near it. So we're afraid that all of a sudden something like Homeland Security will come in and say, this is an infrastructure that's valuable. You can't go within 2 miles, a half a mile, 500 yards, whatever it is of this. That is always, we feel that's one of the Hydra heads.
Yeah, and I think it's good to be thinking about those possibilities. I mean, the industry itself, the wind industry, is already seeing that with each successive permit, there's new considerations that are added. So right now, land-based radar interference mitigation is a concern that wasn't included in the initial permits. Fisheries survey mitigation measures may be coming, and who knows if there's accidents out there, if there might be additional operational restrictions that are not in place now. Well, and this is why this is an entirely biased and self-serving comment, but this is why I think having really robust data systems in and adjacent to those wind farms is going to be key, because we want to make sure that sea state conditions are understood as well as possible, so fishermen and other mariners can make the best decisions about whether to go in there or not. And I think complementing that with everything we're talking about here, with the sort of environmental data that, it may be a beautiful day, but the conditions are entirely wrong for your target species, in which case it's not worthwhile. I think that's going to be a shared interest between the wind industry and the fishing industry, because both are going to want fishermen in those wind farms to fish as efficiently and surgically as possible and then get the hell out. I think that's going to be a shared interest, and that's going to mean having the right data systems feeding into the right models and delivered through the right products, which is why everything we're discussing here is really important.
Let me build on the collaboration point then. I've written proposals sort of across the scientific and industry space, and I've always found that getting more stakeholders involved in the conversations in a collaborative manner will generally lead to success in a lot of different dimensions, including funding. And so what you're talking about is building collaboration efforts between fishermen, wind farm infrastructure, energy companies, scientists, and a lot of other people. And if we can find common ground and find incentives that all of us are benefiting from doing these things, then we have a better chance of being successful. But we do have to listen to everybody involved and take that into the conversations. And I can't remember who I was talking to, but one of the NOAA programs has social scientists that goes out and intentionally goes out and talks to people who are not in the rooms having these conversations to find out why they're not in the room and how we can bring them into these conversations. And I'm not sure that got captured in these discussions, but I would strongly encourage more of that outreach to the people who are not in these rooms to make sure that we're figuring out how to get more people involved, invested, and collaborative.
With the wind farm, I'm sorry, was I jumping on you? I know you're going to say.
The comment.
Well, we have the Mass Lobstermen's. Our executive director, my niece Beth, has been the liaison since the inception and the first contracts and lease agreements with Ørsted, and we have worked very closely with the wind farms and still are. So it has been an ongoing partnership. And all of these things have been addressed over the past years, believe me.
Yeah, so maybe last one, we need to move on to the...
Well, I know in England, the English, they've actually even brought fishermen from England to try to persuade us and be friendly with it. They fish fixed gear, and we've seen pictures of their radars. I'm sure a lot of us have, navigated by radar up against, 5, 6, 7, 8 boats or targets inside of a quarter of a mile. So fixed gear, I think you're okay. Mobile gear, you are blankety blank.
The wind farms actually have, in Rhode Island, we went into it, they have a simulation. I don't know if anybody here has been in there, but they have it. It's almost like going to an Omni. It's very real. It's one of those virtual things that takes us through all of the conditions on the radar. Of course, the Coast Guard was initially involved with the radar in the interference and everything, but this did it in snowstorms and wind and rough conditions, and you went through it all, and it was dizzying on how we could do it all, and it's very difficult.
Sorry, folks. We probably can find out some time later if we feel this is a good area to talk about it. So we have Nora and Hattie for group Breakout 2 summaries.
Okay, so we did one slide for fixed gear, and then Hallie's going to present the slide on the mobile gear. So in general, the trap fishermen did like being able to fit the sensor on the bridge. So keeping in mind for future iterations of sensors that if it's too bulky sticking out from the bridge, then trap fishermen aren't really going to like that. And then I think the gill netter that was in the other group also said that the sensor system that he's had set up has been working. He clips it, I think, with a tuna hook or something. And so people had an interest in creating more fixed sensor stations, or, keeping in mind that there is some movement of traps on the bottom, maintaining at least like a fixed depth in certain areas. People suggested using like a ropeless trap or building some type of sled with these sensors to keep in the same area. And then people like the idea of sharing the sensor data from these fixed locations with the general community via a public website. Both or multiple groups had an interest in being able to deploy multiple sensors along a trawl to see kind of like micro changes along the habitat. And then depending on how long the trawl is, there could be larger or smaller differences. The gillnetter expressed interest in maybe trying to get more gillnet fisheries involved in sensor development. Obviously, the trap fisheries, have been involved with a lot of programs for a long time at this point. Some suggestions for helping improve data access and deployment is having stronger public Wi-Fi hotspots along the Cape. I think even someone suggested, a tech or someone working on a program could have like their own mobile hotspot when they meet guys to troubleshoot some issues. And then maybe adding a bright color or strip on the sensor itself to help locate it if you're sorting through traps pretty quickly. Some considerations to be made for involvement with the fishermen themselves. Troubleshooting sensors, keep in mind that different soak times, you can't expect someone to necessarily fix or check on the same trap every single day or as often if they typically soak for a week or two. In terms of asking if certain forecasting models would be helpful or of interest to fishers, bottom water forecasting models could be helpful, especially on a smaller scale, so maybe just a couple days in advance. And then there was an interest in creating a model to be able to compare bottom water conditions to surface water conditions. There is some interest in tech assistance, using pre-recorded how-to videos, utilizing video calls when you're communicating with the fishermen, so you don't necessarily have to be right at the dock with them. And same across the board, same interest for different data, depth, pressure, pH, salinity, especially for like scallops, temperature, bottom water current, and again, being able to have multiple sensors along the same trawl, you could see some differences just in the region. And then there was some discussion about, fishermen seem pretty protective over their actual catch values. Many guys said that they were like happy to share all their sensor temperature data with whoever was interested. And so maybe one way of getting around this is starting to incorporate more of a qualitative discrete scale. You can say, hey, was this catch in this trawl like bad, okay, good, really good? I think depending on the scale of the project and the fishery, you can set what kind of levels you're interested in, thinking about like different time frames for that. You want to probably compare that catch to the similar area at the similar time of year from year to year. And then if you have just like a button on a tablet or a program, then it could be associated with a timestamp. And then once you get the sensor readings, you can kind of relate it to the closest timestamp from when you recorded your catch quality.
Yeah, so I was in the mobile group, and you'll see there are a lot of similarities between both gear types, but some different considerations just based on the nature of the gear. So for our deployment, multiple folks talked about that so far, like the equipment has held up pretty well, which is encouraging, but there are of course other considerations when we're talking about biogeochemical sensors, such as vibration, sensor drift, the actual size and weight of the packages themselves, issues with telemetry when you have all these sensors together, and also the cost. And then there is a need to kind of standardize connectors and communication across different sensor types, so it's easier for the fishermen to actually implement them all out at sea. Considerations for new packages with larger footprints, especially like pH sensors, they're a lot larger, and yeah, might be a little wonkier to attach to the gear. And with biogeochemical measurements, stirring up the sedimentation could be a problem, which isn't so much a problem when you're talking about fixed gear types, but especially with dredging, if you're like stirring up all the sediment, that could affect the measurements that you're taking, reflecting, respiration or production in the water column that wouldn't be occurring if it was a stable environment. So some solutions for that may be like mounting the sensors up front, so it's kind of ahead of the disturbance, but we would need some testing probably with cameras to look at that. As far as involvement goes, there is a lot of talk about compensation, especially paying fishermen significant stipends, because the cost of ocean observations are high, and as we've talked a lot about, time is money. An example that one group had was that the sail drone cost, I guess, $2,500 per day, so paying a fisher that, they could do a lot with that kind of money. Most costs of ocean observation are from platform deployment costs, so not the actual sensor or the loggers themselves. And taking bottle samples to calibrate our instruments is very doable. Utilizing fishery observers might be an approach for getting some of that paired biological data that we want, but the fishermen don't always have the time to actually collect at sea. And a lot of fishermen talked about how they would like to be able to easily access their own data while at sea, so they can make decisions on the fly rather than like waiting and going back to the dock and like trying to analyze their own data and try to remember things from like weeks or days ago. As far as data goes, there is an interest in really collecting any type of data that would help inform reasons for species distribution. Bottom temperature historically has been collected a lot, but a lot of the fishermen still don't really know what it means for their species of interest. So making maps or forecasts could be helpful. So say they had a good catch at a specific temperature, they don't actually know where else that temperature is at that time. So having some sort of like daily forecast system would be helpful for them. Other data types of interest that came up were conductivity, chlorophyll, and dissolved oxygen, which I think are all pretty easy to add with, when we're relating that to other like sensors, like pH sensors. And then the analysis and interpretation of the data is key, and it has to be hypothesis driven. So like we were talking about with the bottom temperature, they still don't really understand how that's affecting their fishery. So if scientists could kind of help provide that information to them and say, oh, like we've seen this correlation with the bottom temperature, this might be a good area to fish, but you of course also have to take into consideration the management, because some of those areas might be closed to fishing. So kind of having all of that information together would be helpful for the fishermen. And yeah, that pretty much summarizes it. So now we can open up the floor to any comments or questions that you have.
Thank you, Ellie. And Noah, that's wonderful. Open up the floor, comments, questions?
Oh, yeah, just wanted to add one more comment I forgot to mention. I don't know if Linus or Tracy has experience if you use baited traps when you had your DO sensors, and whether something like bait or feeding could affect certain biogeochemical sensors.
It's something that we're mildly concerned about, and after talking a little bit with Jenny, it's something I think that we should probably take a look at, because sometimes we do get some weird stuff in the sensor that doesn't otherwise make sense.
Yeah.
So whether that's a clump of weed, or it's being influenced by the bait, or there's a particularly high catch in that trap, it's something I think is next step to understanding some of the variation. But we think that it's, when we look at it, like we look at it at 6-hour averages, so we think it might be being smoothed over. But it's definitely something to try to understand for the finer scale.
We see more data issues with the pots actually being buried. So if we'll see like a sharp decline in oxygen and all, like, well, typically when we deploy our sensors, they're clustered. You know, each fisherman will have like 5 or 6 sensors, and so they're deploying it close-ish to their area. So if, you know, if you see one sensor that's just tanking, like, okay, it's probably buried. So
In doing some deployment of CTD, making CTD casts, so we try to keep it from coming into contact with the bottom, but we want to come as close as we possibly can.
Right.
And in the couple cases where we have bottomed out, you know, you see crazy spikes and anomalous data there.
Yeah, I think for the shell fleet, Frank just uses the upcast in his analysis to kind of eliminate some of the variability.
All right. So let's continue Breakout 3 summary. Connor?
All right. Well, I have the mic. I just want to say thanks for having me this week. It's been good to meet everyone, and I've learned a lot from all of you. And so in the Breakout Group 3, we talked a lot about data privacy and what we would want out of different data products. In terms of privacy and what people felt comfortable with being public information, right, with current technology required on vessels, basically the location of fishing activities is not a secret, so that's not something anyone is holding super near and dear. And most fishermen seemed willing to share environmental data publicly. There were some ideas about how to bin that data spatially, so it's not super well resolved in space, or maybe have it released a little bit after the fact, so that you know, you can see your own data right away. But there's generally a willingness to share, so long as this data isn't used to police fishermen, right? Because I guess there was talk about sometimes you start a trawl and currents can carry you, you know, over the edge of like a boundary maybe where you're not allowed to fish, and right. So as long as the data is not used to police them. And then the piece of data that is problematic to release is catch data, and there are privacy concerns around this, and also laws preventing its release in a lot of cases. Yeah, so for privacy, that's what we talked about. As far as what's needed in data products, we really kind of dove deep here in a lot of ways. What is wanted, the low-hanging fruit, is at least, you know, a centralized web page that shows all of the available data products, so that they're easy to access. And then also, even better would be one browsable, sort of interoperable data portal, not necessarily a centralized database, but a portal where you can look at all of these data from different sources and visualize it in one place, and potentially download it if you wanted to use it for something else as well. Some of the feedback we got on different things that we talked about this week, some fishermen might not be interested in utilizing a complex forecasting product, but there was a want for better tidal information. So that's one thing that does seem to be desired. Habitat suitability indices could be useful, but at least one of the fishermen in our groups wanted to field test these products before they could be sort of trusted and utilized. And then they could also be really useful for bycatch avoidance as opposed to, trying to identify productive fishing grounds, identifying grounds to avoid to minimize bycatch of problematic species. And of course, scientists would be interested in more biogeochemical data. No surprise there. Let's see. More specifically, commercially available data products could definitely benefit from finer scale data, and these are a lot of like the common ones that fishermen are utilizing. And so that was one way that these data sets could benefit existing products. And then different fisheries obviously will benefit from data products that exist on different scales. So in any data products that are developed, it's important that, the time scales and spatial scales can be, selected based on the application and what fishery. And as far as, features of a data product, definitely like one common theme throughout the week is these programs should be simple. They should be familiar, right? There are definitely software that the industry is using already, and if they can be, similar to what is already in use, then that'll make it more easily integrated. And best possible would be to integrate this stuff with pre-existing products. So we definitely heard about a few products that are already on board on vessels, and if you could integrate this data and the stuff coming directly off of the instruments with those products, that would be definitely ideal. And then, right, there also is recognition that different, the older and younger generations of fishermen are going to adopt different practices with regards to what products are useful and to what extent they might want to integrate them with their operations. And I guess to summarize here, right, these products need to be built in a way where their usefulness is easy to communicate. So we can go out and say, like, this is something you might want to try using in the fleet, and this is why. And then also, when using the product, the effort to interpret it has to be very minimal, right? It has to be a product that's just easy to look at and easy to map back to what your catch might be on a given day or how you're going to plan your operations for that day. And this might mean multiple fishery-specific or user-base specific products. So there might not be one catch-all solution, and they might have to be instead tailored for the region or the type of fishery that they're being used in. Yeah. So any comments or, yeah.
I spent probably several decades using GIS products, so geospatial information relating to land use mostly. Some of the problems that I think that we're seeing, and I'm very new to this space, so please forgive me, about centralized availability for data products and things like that may have already been solved in the GIS community in terms of a federated model for announcing what products you have available and thus making them easier to find and access. So this a place to look for existing models for how to go about doing this.
Just follow up on that. So you talk about the centralized website. So we had a little conversation on the table. So I just want to get some feeling from, for example, Dwight mentioned we don't want to reinvent wheel, but then there's a clear need that people want to aggregate it website to their data together, not just their data, probably other groups' data to help to make.
Can I trump you, Dwight? For online people, Liz Parati, Ocean Acidification Program. So it's interesting to see this summary because the message I've been hearing, especially from the fishermen this week, is that really the data products they want are the ones on the vessels. And I think that we've also talked about that there are so many data portals that it's hard to know which one to go to. And now I'm starting to question like the utility of creating new ones. If the users, the downstream users aren't tapping into them. And so I think we need to take a really hard look at what we have. We have ERDAP, NCEI, we have all these other apps. and how to really deliver the information that we need to the different stakeholders. So I'll just make that comment.
I think she nailed it. My question to the fishing community is, when you wake up in the morning and you grab your cup of joe, where do you pull up? All right, you pull up your weather. So I don't know where you go and currently acquire information. And I'd like to know that, because that's where I want to put this information as a supplement to that. When I pull up a weather report, I pull up one website and it tells me temperature and humidity and chance of rain. I don't go to different websites to find out each one of those criteria. So I want to know where you guys are already frequenting, to gather information.
I just wanted to add a comment here about also, the difference between a data portal for direct access to the data versus a value-added product, access to value-added products. And so I think both need to be considered as part of this discussion. There are already some really fantastic databases, web-based, databases where we can put data, we can access data and get it out. But I think, understanding what the value-added product is and how to share that is going to be a key part of this conversation too.
I confuse things by wearing multiple hats, so I'll put on an industry hat for a second, and somebody new to the space, and sort of echo what everybody else has said, that understanding where people who are new to this conversation can come in and contribute it's a lot easier if there are, hey, this is where most of the data is going, or this is where you can add value to it. And I look across sort of the space, and to your point, there's a lot of portals, there's a lot of databases out there, and understanding how to start contributing can be complicated. And so that's that's one of many reasons for sort of going through and doing a catalog or survey of the current products that are available, identifying which ones are the ones that the fishers go to, the contributors are going to, and saying, okay, it's not perfect, but this is where most of the concentration is, and let's build up from here instead of building yet another thing.
I was just going to add another comment, similar. I think that was a really good point about where do fishermen go or what websites. I think there's a multitude of weather apps, whether it's Windy, iWind, weather.gov, fish weather. And so, many fishermen use their own, but I think that's a really good point, and to maybe check in with them on the ones that they rely on the most, because they'd be excellent platforms for additional information to be added to.
Under the emo.org site, there's a link to something called Navigating Portals. And so there's a list of several portals available for ocean data, a little 3-minute video on each on how to get through and what they supply.
Thanks, Jim. I've got a few things to say here. Hopefully do it quick. And the first one is that I think as scientists, we need to kind of check our scientific bias. It's like, we're like, oh, we want to build a data product. We want to provide analytics. Whereas the fishing industry, they're used to dealing with a lot of weird raw data all the time, like all this acoustic stuff. And so like that decision-making process for many of the folks that I talk to, like they're real good at dealing with temperature data and using that. So, doing these analytics products and stuff like that, I think that's important. And then the complete flip side of that is like Windy. And so like the baseline thing that you get on when you go on Windy, that's the ECMWF model. So that's the European model for the wind in this condition, in this region. And that again comes into data management and putting the data to work. So we can put that data that you're collecting, we can put that into the ocean model that's initializing the ECMWF model. So, working on this, and I think that's a key thing to document, is like we can make sure that we're improving the stuff that you guys are relying on. But I think then we need to make sure that you're aware of that. And I think one of the things with John Wilkins' talk is like, if you guys go overboard or have an emergency, like the Coast Guard are going to be able to rescue you better because of what you're contributing. And so I think, that kind of full data, there's lots of different data usage. And so just making sure everyone's aware of all those pieces, I think.
Back on your initial question of what we do, basically, if we're day boats in and out on the same day or within a short period of time, the two things that we want the most are wind speed and wind direction. whether it's raining, snowing, or anything else, I'm under the wheelhouse. That guy out in the back is the one that's got to put up with it. And we do use windy, and we were just sitting here saying, both of us use windy, and we didn't know it was a European model. And if anything that we put in might help modify it, it's pretty accurate or whatever. And basically, my philosophy at this point in life is I go look, and my interpretation of weather is whether I go or whether I don't go. So, but that's about it.
Hassan Mustafid from NOAA, and I am sitting in Integrated Ocean Observance System, and I'm hearing the discussion. This is all good stuff, but I can tell you that the key here is simple, familiar, integrated. To make this happen, you need a data standards. To integrate all this, and I think the other group really, mentioned that. They mentioned the data standard is a key really to put all these things together. But guess what? Right now, we have a lot of sensors, and they are not interoperable. Even the sensors themselves that we have right now, I would say you're not going to be easy even to integrate that data from them because they come in different format, different shape, different. But then to go further and make this, nobody is going to stop these people making data portals. There's no way. But what can help them to make this? Because everyone wants to build something for himself, right? You want to build your house. You want to build. You don't want to live in the same house. Standards that you are pushing out there, and I think Cooper just mentioned that to be able to do all that, you need to really to focus on standardizing the data in the way that everyone can use it and build what he wants. Build his house and put. Like ERDAP, someone mentioned ERDAP. Well, ERDAP was built by NOAA as a middleman to bring all those different type of data and fill it out in different formats that anyone can use. So I think the key is for these communities to have that vision. I think I've been talking about the vision about how you want to build this whole community together is to make some standard for the data itself. Okay? Data quality is a key of all this. The scientists are not going to pull this data if they are not good.
I think we're behind. Maybe quick comment?
So some shameless promotion from our program, Ocean Acidification. So one of the first things that we did as a program about 10 years ago when we stood up is we aggressively engaged on that standardization of metadata. And we've spent 10 years developing a rich metadata standard that is extremely dynamic and accommodating a broad range of data, and not just BGC data. We're able to port into the same. And if you go to our website, you can go into the data metadata system, and you can populate it with experimental data or whatever you. It's extremely dynamic and versatile. So I would just suggest looking at that before we reinvent a wheel that I've spent a lot of money building in 10 years. So.
All right. Dave, do you want to say?
To underscore those last two, standardization and metadata and those things are incredibly important. And a lot of that work's been done, 10 years of effort. But if we don't adopt existing standards, it doesn't matter, and somebody's going to create something new. And so stepping back and coming together and figuring out, okay, what's already out there, and getting the people that are new to the industry to come in and say, okay, I'm not going to go build my own thing. I'm going to build on something that was already done, is going to make this a lot more useful. Otherwise, 10 years from now, we'll be sitting here and I'll have come up with 10 years of metadata for describing something differently.
Okay, I think it's time to move on to the panel. So if our panelists could make their way to the front of the room, please.
So next session is going to be panels from agencies and existing observational programs, national, international, regional. I'm gonna just give a mic to the panelists. I think each panelist has about 5 minutes to talk about their stuff. Some may have slides, some may not. And there's an online one from Maracus. So let me introduce the first panelist, Dr. Dwight Gladhill. He's with the Ocean Acidification Program at NOAA.
So Alec gave us kind of a vague description of what we need to cover. So I don't know what I'm going to say, but we'll figure this out. But what I want to do is to kind of tell you who we are as a program, why we're interested in this, our motivation behind it, and some thoughts coming from a program that has invested for more than 10 to 15 years on observing systems, and why I'm very excited about what you've all been talking about. Okay, so NOAA's Ocean Acidification Program. They're about 10 years old now, and a lot of people think of us as an observing program. In fact, we're not. That is an element of what we do, but our charge is really to understand the potential risk that ocean acidification poses to U.S. marine resources and the industries. And that requires us to do really three different things. One is you actually need to document if there's any change happening in the environment, in our case, the chemical environment. The other key piece of that is finding out if that has anything to do with the biology that lives there. And then the third element to that is, does anybody care about that fish, right? Which is all of you. So that's what we do. That's kind of our trifecta of investment areas that we do. About half of our investment on any given year is, in fact, trying to describe that environment either through direct observations or modeling. If you go to our website, you'll find all kinds of information. One key thing that you'll want to look at to see how this, what you're talking about, this observing system might fit in our priorities is to access this Ocean, Coastal, and Great Lakes Acidification Research Plan. This is kind of our 10-year guiding document, and you will find in there a lot of instances in every single region where everyone says subsurface. Subsurface. We don't know what the hell's going on in the subsurface. And I'll explain to you a little bit why that's happened historically. So these are our fixed observing time series that we have. The Gulf of Maine is actually, I think, one of the longest time series that we have, going back, God, almost, 15, 16 years or so, roughly. Don't quote me on that. These time series were established at the surface where they measure both the surface seawater CO2 levels and the atmosphere, with the sole purpose of trying to quantify air-sea flux of carbon. They were an air-sea flux observing system. Now, Congress told us, start an OA program, and by the way, don't build your own system, take what's there. So we've adopted an observing system where its primary charge was looking at the surface chemistry. And Congress keeps telling us, so what are the effects on the biology? And we're saying we're struggling because our whole observing system is at the surface, and they all live at depth. So historically, we have this observing system which we've maintained. It's giving us a lot of valuable insights. This is a modeling exercise that was run by Sam Solecki's group. A bunch of us run that paper. Alec was on that paper. And this looks at the time series in the Gulf of Maine, and we can apply a couple of different modeling scenarios to it and examine, what a year might look like now versus what it looked like, in the year 2050. And what we find, this is saturation state, which Alex went through very briefly before, but it's an indicator of when marine calcifiers really have to be putting in a lot more energy to make their shells. Okay, it means that they got to put in a bigger investment to that. When it gets yellow here, that's potentially marginal, according to the laboratory. We do not have this carefully validated in the field, which is why your data is critical. Okay? So here's another look at that model, looking at it spatially. We looked at a couple of different models. And again, our observing system has been historically at the surface, which are shown in these upper three plots. There's three different model scenarios looking at the year 2050, assuming we don't get our crap together and actually curb our emissions. Key thing to notice is that the bottom water is vastly different than the surface. And under these emission scenarios, the bottom waters potentially become quite corrosive to these marine calcifiers by about the year 2050 in certain areas of the Gulf of Maine. Importantly, probably not Georges Bank, which is an important refuge. Okay, so Those are our fixed time series. They're great. They give us some nice long-term idea of how things are changing in one spot. But we do have some efforts in place to look at the entire water column, and these are executed primarily by our large-scale geochemical surveys. They come and they pay a visit to you like a bus. Every 4 years is when we occupy these waters, okay? Because that's the frequency in which we can actually, those are the resources we have available, the vessels we have available. Science teams make up between 20, 25 scientists on these cruises. These will be really valuable for validating and verifying the data sets you're proposing to do, right? This is your ground truth. This is the gold standard, but your gold standard only shows up once every 4 years. Data synthesis, just very briefly, this is a nice product that we funded that took all of the coastal data that's been acquired over the past 20 years on in the continental shelf areas, and it's compiled it into a single data product, which you can now access. And this is not a static product. The intent is going forward, we will be assimilating more and more data into this, but it will give you a one-stop shop to acquire all the synthesized data. And so a product like this, if it's carefully validated, would fit nicely in there. Okay, some real quick thoughts. Hopefully I'm not too late. Closing thoughts. Our congressional charge to NOAA is to ensure that our acidification science meets the needs of you. And I love the generosity of this audience because over the past 2 days I've been hearing about, we can do this and this will help inform your science and understanding. Love it. But at the end of the day, I really want to figure out how I can get that science to help you, okay? We work for you, not the other way around. And so I think together, we're actually going to be able to help each other out. And partnership is king, and you're going to be hearing from Jake about the regional IOS associations, which I think would make a perfect epicenter for advancing something like this that our program can work closely with. We already work very closely with IOS. But the science co-production is key. We've gotten very good at assimilating biogeochemical data, like I showed in that last slide. But again, I don't really know what those trigger points are other than outside of a laboratory. All the other data that you're collecting, that's the data I really need to know. Was it a bad day? I don't know. I can tell you what the biogeochemistry was, but I don't know if it's a bad fishing day. So it's as equally important that you think about sharing your fishing information and your observations in the field with us in some standardized way so that we can relate the two. Right now, there is a coastal acidification network in your region, whichever region you're in. These are a nexus of federal, state, sea grant extension agencies, industry partners, and they are being charged right now through congressional legislation to help us as a program set our monitoring priorities going forward. We actually have to report on this. So I ask you to go to our website, find out your regional local CAN, engage with them, figure out how you might be able to contribute to helping to inform that prioritization because that's coming on the wire right fast. I'm a bean counter. I'm the deputy director. That's what we do. We lay down the fat base in the background of the program, and bean counting is my primary bread and butter. What I'm looking for in these discussions is a full costing of what it is you're proposing. And the costing, and this has been mentioned before, is way, way, way more than putting an asset in a lobster pot. Most of the investment of any observing system is staff time, staff to do the data management, QA, QC, product synthesis, all of that. So that's all I got. Sorry, I know I'm over.
Thank you. That's wonderful. Then we have IWOS Representative Hassan Moussaid.
Yeah, thank you, and thank you for the opportunity really to be here. I'm always pleased to be with fishermen and talking to fishermen. It's always nice. And so before even to start with that, I just will just share what we do, okay? I'm not going to the science today, not today. But I think this is very important to know for us all, that things are real and things are happening. And the key of all this is really answering those questions. What is changing? What is, why it is changing? We want to understand all that. How will it change, how we can forecast all that, and how to respond to them. And this is the big stuff, okay? To do that, this is how it looks, those needs for everyone. When an observance system is set up, try to figure out which time scale we are going to take these observations. You can see how complex everyone is pulling their way from different directions. And this is just talking about fisheries. In the bottom there, you can see the scale of fisheries where it is operating basically with those management and annual catch limits. And if you look forward for climate, that's even harder. I'm not going to go deep into it, but you can see the time scale for each need is different. And so in 2009, the Congress decided to create this enterprise called Integrated Ocean Observance System. And it has to respond to the regional, national, and the global. And it has been, we have 11 regional associations, Neracus and Maracus that you are familiar with, but there is 11 of them around the country. And that's the key for all this enterprise. And then there's 17 agencies that we have to work with. And then we have to respond to the global scale, since we are part of the global. And so just to show you that when I said standards and all these observations that you're talking about, the key in this integrated ocean observance system is the integration. Okay, how we can bring all that data, all these things, and put them in the way that, we can use them. And that is standard, interoperability, all those good stuff that you heard from everyone today. And I'm showing here a few products. You can see the glider network. You can access those data freely on those portals. And you're not going to say, no, I'm going to go with one portal to do everything. That's impossible to do. It gets confusing. And so the right one is where all the sensors that we have globally is in that. When you click on that hexagon, you're going to drill all the way down to that sensor within that area, within that hexagon. And then the bottom one is more interesting for everyone here, for the fishermen, is that all the models that we have in the country are being pulled into this system, and they are real time. And so I'm just showing one here from Maracus, the Doppio model, the water temperature. But you can click on all these models from Neracus, from Maracus, from all the regional associations, from the Navy, from NOAA, from everyone. It's just showing you that products are out there. High frequency radar, all of them are right there. I can't remember, Jake, is it 100 something radar so far? We haven't, nationwide, 100, 120, 128, 130, something like that. So this is an interesting one for what we're doing here, because we've been funding all these manufacturers build these sensors, but the problem is that most of them are in R&D. They are for research. And how to move them to operation is a whole different, And so we've been doing this. We've been basically funding these sensors and these technologies to move to operations, and how we can test them. And we work with Alliance for Coastal, where they do testing and validation. But one project, I think Jim was funded with this project back in the time to do his testing of his instrumentation for EMOLs. And I think recently also they've been, I think Neracus, and you're part of that, Jake. And so they've been doing testing the telemetry and how to move that telemetry to operational. I am over. The next one is the data quality that we've been talking about. And we've been really working hard to get data quality for all real-time observations, biochemistry, biogeochemistry, all these things. So Quartode is one of them. All those manuals are available. All that, basically all the service is available to anybody to use it instead of creating new wheels and stuff. But I think it all comes to people. Without these people, this enterprise could not exist. this is all regional association directors, 11 of them, and then there is other people in there. I don't know if you can see Jake there, but I don't know. But, you know, this make this happen. So I will stop here. Thank you very much for the opportunity.
Thank you, Hassan. Hassan is, I forgot to introduce, you still are the acting director of the Office of Science and Technology?
No.
Not anymore. All right, next we have a remote speaker from Maracus, Dr. Gerhard Kuska.
Hello, I'm Gerhard Kuska. I hope you can hear me okay.
Yep.
Great, thank you. Well, I appreciate the speakers before me, and I'm sorry I can't be with you, but I'm very happy to be part of this. Maracus, as one of the 11 regional associations, you'll hear from Jake Kreitzer, my colleague from Maracus, in a moment. As Hassan said, we make up the non-federal part of the U.S. Integrated Ocean Observing System. And one important point I want to start out with is that each of the 11 regional associations is certified by NOAA and IUS for the work that it does, indicating that the data you receive, whether they're collected by the regional association directly by its partners or leveraged from other partnerships, all those data need to meet federal standards in order to be served out to the community. So in essence, you have an extended arm, you have an extension of the federal partners in terms of the data, not just the data collection, the data availability, and the chance to enhance products or create new products, which you'll hear about a little bit more in a second. Why this is important is because it really gives credibility to the work that's done by the partners, and so much so that NOAA extends tort liability coverage for the purposes of this work. So, I mean, that's a huge sign of confidence in this certification program. Next slide, please. Now, we're ingesting all kinds of data, and much of it is going, well, if it has a federal data assembly center, is going into one of the many federal data assemblies or the GTS to be available by NOAA, by Army Corps of Engineers, by any agency that has an interest in utilizing, accessing the data for their own purposes or for their stakeholders. In terms of accessibility, I just want to point out that each of the regions has a way to give you, the community, access to the data. So while there are machine-to-machine transfers where you can go through federal portals, you can also access those data through the regional associations themselves. Maracus operates the Maracus Oceans Map, which in partnership with our partner RPS in Rhode Island. We just released the third version, a next generation portal that brings in together all the federal, all the non-federal data models. It offers a variety of advanced tools, including model data comparisons, a new traffic light tool with upper and lower boundaries for decision makings. It's now mobile friendly. It's customizable and savable. It's shareable with colleagues. We'd love to give folks who are interested a demo, and we're happy to work with our partners to adapt the tool for your purposes. You can take a look at it yourself at oceansmap.maracus.org right there. Next slide, please. Now, we've talked about ocean acidification in the Mid-Atlantic. We support, in partnership with MARCO, the Mid-Atlantic Regional Council on the Ocean. That's our regional ocean partnership made up of the 5 states, New York, New Jersey, Delaware, Maryland, Virginia. MACAN, our Mid-Atlantic Coastal Acidification Network, which is, was started after NECAN and SOCAN were started. So we are younger in terms of our progress, but we have a strong partnership that is developing to better understand ocean acidification drivers in our region, some of the consequences to our resources, and coordinating a little bit better on developing monitoring, data collection, and so on. I'll mention my colleague in a moment, but we'll go to the next slide, please. Actually, I think this is one of those that has a lovely little. Keep going, please. One more. I should have removed that. Keep going. because I know I only have a couple of seconds left. I want to mention that there are a number of topical areas that you're aware of, but that are driving a lot of the other work. Obviously, the development of offshore wind off our coast is resulting in new partnerships. The Regional Wildlife Science Cooperative, the Responsible Offshore Science. Actually, ROSA is the partner to RODA, but dealing with fisheries, fishermen, and offshore wind. We've got developing data sharing agreements and are acting as the extended arm for the IU's federal partners in terms of data management and trying to bring in a lot of the new data that's being collected. These data can help improve a number of applications and products that are important to fisheries management, and to fishermen. And it's also an opportunity to help define some of the gaps that we need, because there is an interest by some of these partners to fund additional data collection. And it's a question of what needs to be funded and where that priority is. Acoustic telemetry, we continue to support ACT Matos, which is a part of the Animal Telemetry Network. And marine carbon dioxide removal has becoming a more prominent topic. It's being discussed now, particularly in line with some of the funding that may be coming up in the future. We see opportunities to support with modeling, with observing, and developing that community and the stakeholders. And I mentioned fisheries and fishing. We were talking about fisheries and the fishing community, but I think what I want to mention here is that we want to hear from you. We want to talk to you. There are ways we can support boater safety. There are ways we can support more efficient fishing, bycatch avoidance. A number of tools are in place. There are some around the region that may not exist in where you're fishing or where you have an interest, but we want to make sure that you're aware that there's a dialogue so that we can begin to support you better and build on the trust that I think a lot of our partners have built with the fishing community and with the fishery managers over time. I've listed our names there. Garrett Kuska, I'm the executive director. Mary Ford, my colleague, who is also the co-chair of MACAN. I will stop right there. Thank you very much.
Thank you, Gerhard. That's wonderful. Next, we have Jake Kreiser from NARACUS.
Thanks, Alec, and I really want to thank Dwight, Hassan, and Gerhard. Their comments took about 4 minutes worth of the 5 minutes of remarks I would have made, so hopefully I can get through this a bit more succinctly. I'm going to make 3 points, I think, related particularly to ocean acidification monitoring, pH, carbonate chemistry, et cetera. This map I've shown here is from the paper that Sam Sidlecki led that Dwight showed a few of the images from, and it tells me a couple things. First of all, is that we have a lot of OA monitoring going on in the Northeast, but 2 things. One point that Dwight made is there's not much at depth. There's a lot of surface monitoring, and most of it is not sustained. There's a number, particularly ECOA cruises, a number of kind of episodic monitoring programs. But as far as continuous monitoring, it's fairly limited right now. What we do have, I mean, Dwight characterized OAP as not being an observing program, which may be true, but has been absolutely essential in building up observing programs. So OAP fingerprints are all over a lot of what you see there and a lot of what I hope is to come. But I think we do have scope for growth to try to move that along. We are involved, I think, in 2 important initiatives. Gerhard mentioned NECAN, the counterpart to MACAN and SOCAN. So this is the Northeast Coastal Acidification Network. It brings together a number of researchers, managers, and industry members across the region, including up into Canada, that is trying to move forward monitoring and modeling activities. We're also the coordinators of the OA Information Exchange. This was originally envisioned as essentially a national social media platform for OA nerds. It's actually become fairly international in scope. I think by last count, about a quarter of the members of OAIE are from outside the US. So that's been really encouraging to see. That tries to do something, I think, similar to what NECAN does, but at a larger scale and in a virtual way, is to connect people with different interests, whether they are scientific, policy, or economic interests in OA issues, to try to advance those monitoring systems. My view, though, is that if we really want to build up OA monitoring and probably other BGC variables as well, we're going to have to make a stronger use case. That the scientific understanding is important, is I would say necessary, but not sufficient to getting the kind of support and investment that we need. This workshop has been a breath of fresh air in that direction. It is great to see fishing industry members here. It is great to see so much discussion, not just of the scientific issues and the observing programs, but how we actually put these data into use. Through NECAN, we've tried to move in that direction as well. The industry work group in NECAN, which is a mixture of shellfish aquaculturists and wild shellfish harvesters, conducted an industry survey a few years ago and produced, I think, a really interesting report that was trying to gauge what is the level of understanding of OA issues among shellfish growers and shellfish harvesters, what are remaining questions, and what are the priority needs. More recently, through a project that was jointly funded by OAP and NCOS, we developed a BGC model and then took the outputs of that to a series of focus groups to try to say, okay, does this look like a useful product? How would you actually put this to use? So I think together those are examples of efforts that, again, I think are very much like what we're trying to do here, which is to build up this use case that from what I've seen is going to be essential for getting that sustained investment, sustained support in these systems. And I just want to let you know about a forthcoming opportunity, though, to continue to build out these monitoring systems. Our friends at NROC, the Northeast Regional Ocean Council, they were allocated through the bipartisan infrastructure law funding for a proposal they put together covering a range of really good and relevant work, including building out OA monitoring infrastructure. This is really picking up and growing several of the objectives that NECAN has outlined in recent years. And so in the coming months and years with NROC and other partners, NECAN is going to be continuing its longstanding webinar series, but with an increasing focus on tools and applications for monitoring. That will lead up probably later this year, but we got to get our act together on planning that, a regional workshop. That those together will be designed to inform development of a regional OA monitoring plan. Now, as we're developing that plan, though, we've got some modest funding in this proposal, even as the plan is being developed, to start expanding monitoring. We're working with Alex Lab on testing and deployment of some of the low-cost pH sensors he's developing through eMolt. We're also working with Brian Helmuth's lab at Northeastern University to deploy low-cost temperature microsensors. Now, they're going to be measuring temperature, not pH, but they're designed to get kind of into the interstitial habitat in rocky intertidal zones, really to start to gauge habitat suitability. I mean, to me, a question is, are the thermal thresholds going to be sufficient to even worry about future pH impacts in the rocky intertidal? My sense is that the rocky intertidal actually doesn't get enough attention when we talk about OA. There's a lot more focus, I think, on scallops and oysters and larger kind of shellfish beds, but these are really important habitats ecologically, and I think the OA community needs to start to pay more attention, and the work Brian's doing, I think, is helping with the habitat characterization there. So that's all I have. Thank you.
Thank you, Jake. Great. Next, we have Al Plutman from OI.
All right, thanks for inviting me, Alec, and thanks to Heather and everyone else who's organized this. I'm talking about a program you maybe haven't heard much about yet so far, the Ocean Observatories Initiative. This is funded by the National Science Foundation. It's really a research providing data for researchers sort of program. and has many arrays around the world's ocean. One of them is the Pioneer Array, which is most relevant to this group. It has been on the New England shelf at the location you see with those square boxes and dots. Those are the operating area for moorings, for gliders, and the dots are the moorings. It's been there since about 2013, and it is, in fact, gone. We have, per design and plan with the National Science Foundation, it has been recovered for the last time, and it's going to be moved. In my next slide, I'll tell you about that. But let's talk about the one about the New England Shelf Array. The data are available and have been since the beginning publicly available. They are relevant to this group because in addition to the typical things you would expect, wind speed, wave height, temperature, salinity, currents, we do measure air-sea PCO2, so you can compute a PCO2 flux at the air-sea interface. We also measure CO2 and pH in the mixed layer, 7 meters depth or so. And at select locations, we also measure pH and PCO2 near the seafloor. So some of that, you've heard about what do we do at depth? Well, we have the ability to provide some pretty unique carbon system data at depth, and it's pretty, it will be of order 5 years worth at least of deployments in this new area, and there's 7 years or more of data from the New England shelf if you want to look back historically. So the data are available, as I said, so one more data portal, right? Oh boy. Well, the thing to say here, I think, is that we are committed to interoperability. We use fair data principles. We have a machine-to-machine interface. The data are, metadata are well documented, and so exchanging these data with other entities is very doable. And I think that putting OOI in this session was very smart because I think the way to go here for our data is to work with the IU's regional associations. We're already doing that. We're supplying wind speed, wave height, and surface conditions, but I think it is very doable for us to grow that and supply carbon system data to the regional associations, and I think that's the right aggregation tool for us. So what about relationships with the fishing industry? During the planning phase, there were many different discussions with commercial fishermen in very different forums, and some were much more successful than others. The one that was the most successful by far was discussions with the Commercial Fisheries Research Foundation, CFRF. You've already heard from Glenn Gawarkowitz and from Aubrey Ellerson. A hero and a heroine who've helped make this work, and there are many others, really too numerous to mention, but the reason I talk about that is that how did we make it work? It comes down to people, comes down to being in the right forum with the right people, building a relationship, building trust. We've heard people talk about that before. It's not simple, and it takes time, and it takes people to make a commitment. So that's how it worked. As I say here, the relationships, particularly with CRF, have been ongoing and has really developed into some pretty remarkable products like the Shelf Research Fleet, which you've heard about. So we are about to move the Pioneer Array, as I said. It's going to be relocated offshore of Nags Head, North Carolina. I'll brush over a long, complicated process by just saying this was orchestrated by the National Science Foundation. It was according to a programmatic plan that the Pioneer Array would move after some amount of time. It was done well, and the community weighed in, and it was not us in OI that decided to move it, it was the community. So we're implementing their plan, which is to move to this location. And we have been working really hard behind the scenes to figure out how to do this. There's all kind of programmatic stuff we have to go through. And we are just about to pass that hurdle of getting the approval to proceed, and that will kick off in a few months, basically. Our goal is to start moving towards engaging with the fishing community in a process similar to what we did for the New England Shelf Array. The goals are to establish a means of exchanging information. We've heard a lot about that here. There's so many different ways to try and do it. And we'd really like to find some value-added efforts analogous to what was done with CFRF. And frankly, I don't know what the analogous organization or group is in this region, and so we'd love to hear about that and learn more about it. I think there's an opportunity for better integration with the NOAA study fleet, and I'd like to learn more about that. And as I said earlier, I think the reinitiating, we've already done it, but I think we should start again with IUs and say what products do we have, what products are worth integrating. We can obviously redo what we did for the New England shelf, but I think we should add more variables and more products. So I'll stop there. Thanks.
Thank you. Last, we have Kelly from AOML NOAA Lab in Miami. She's going to talk about the BGC Argo program.
Hi, everyone. My name is Kelly Montanaro, and I'm a NOAA affiliate at NOAA's Atlantic Oceanographic and Meteorological Laboratory. So I've been able to talk to a lot of you during this workshop today, which I'm very grateful for. But right now I'm going to put on a different hat and present on behalf of my colleague, Dr. Emily Osborne, from the Biogeochemical program from the Argo Float program, who couldn't be here today, but wanted to share this information in the session with you all, just in case this kind of data, this kind of program might be interesting to you. So this program, if you're not familiar, looks at biogeochemical parameters specifically, but the Argo program overall is a global array of autonomous floats, so the yellow thing is supposed to be, that measure the upper 2,000 meters of the global ocean. So this is a program of the Global Ocean Observing System, and it's used to fill in data gaps in ocean observations. So my home lab, NOAA Atlantic Oceanographic and Meteorological Laboratories down in Miami, Florida, provides operational support for this global array of, global array of biogeochemical floats. And we do have the U.S. Argo Data Assembly Center that's located in Miami at the AOML lab. And that receives and QA/QCs the data for the 6 BGC Argo parameters, which are listed up there, but that's looking at the normal ones, temperature, salinity, but also oxygen, nitrate, pH, chlorophyll A, via fluorescence, and particulates. And pressure, of course, to see how deep they're going. So AOML is also in the midst of deploying a pilot array of these floats in the chronically underobserved Gulf of Mexico, which we touched on earlier in this workshop. And these floats were recently deployed in the fall of 2022 during the Gulf of Mexico ecosystem and carbon cruise that was on the NOAA ship Ron Brown, which we saw in some pictures earlier today. And this map here shows where that deployment occurred. So the objectives for these floats are, to look at the Gulf of Mexico, to add information on ocean acidification and drawdown of CO2, which these are conditions that coincide with initiation of harmful algal blooms and impact of extreme weather events such as hurricanes on ocean biogeochemistry. So if you're wondering what these kinds of floats look like, there's our colleague Claudia, who is the data manager for this program, standing next to one of the floats. I mean, they're not tiny, but they're not super huge anyways. And these are the Apex floats that measure all those biogeochemical parameters that I mentioned that were deployed in the fall of 2022 during that cruise on the Ron Brown. So these are monitoring the 6 core biogeochemical parameters. Again, chlorophyll A, oxygen, nitrate, pH, and suspended particles, as well as temperature, salinity, and pressure. And you can see a close-up of where these sensors are attached onto these floats. And I wanted to show you what their float mission really looks like. So this is just an example of how they're moving through the ocean. Again, these are autonomous. They're doing their own thing, just swimming around in the world's oceans. So what you do is you just drop them off a boat, either a NOAA research cruise, other, cooperative research cruise, or increasingly we're using the Ship of Opportunity program, which is partnering with industry ships that are already going out. We just go on there, put a scientist on there, they throw them off. These things swim around in the ocean for a while. So generally you drop them off, they descend to their target depth, which you can see. They drift around at that level for around 9 days. Then they go down to their profile depth, begin that profile ascending to the surface, where then they'll be able to transmit their data via satellite have to be the service to be able to reach that, and keep on repeating that profiling mission until our batteries die. And these things last for about 6.5 years, which is pretty crazy. And then we try and pick them up and find them. So the ARGO program has collected, processed, and distributed over 2 million of these vertical profiling missions since the program began. It's, again, focusing on the upper ocean, so that, top 2 kilometers in the past 2 decades. It's important to note that this is an international collaborative project involving 34 countries, and there's been more than 15,000 floats total deployed. So it's got nearly global coverage at this point, and that's been pretty useful in looking at climate change signals, estimation of the global ocean's heat content, and observations for intensification of the global hydrological cycle as well. And it's super important to note here. Oh, no. All right, sorry. Thought I updated on the slide, but I'm not seeing it pop up. But all this data is freely available. We talk about lots of data sources. This is all available on NOAA's NCEI, or the National Center for Environmental Information, which is where a lot of data ideally is housed. I know it's kind of a mess, but it's working towards the centralization of data. But if you're looking for it, just search NOAA Argo. It's also hosted on our AOML website, but honestly, it just shoots you to NCEI. So if you're already used to using that for looking for data, just type in Argo, and you can find it, or just honestly search it on the internet, you can find it. I apologize. Feel free to email me, Kelly Montanaro, or Emily Osborne, and we're both at NOAA AOML, and we can put you in contact with anybody. If you're interested in looking at this kind of data, interested in where it goes, there's a map that's live, giving the GPS locations of all these little guys floating around. And it's great because these are already widely used in ocean and atmospheric models, but if you're looking for more data to feed a model, this could be a good source for you. But again, presenting on behalf of my colleague, so talk to me later if you want to be put in contact with her or one of the other scientists at NOAA AOML that work with us more closely than I do. But just wanted to make sure that I shared that with you all, and thanks for your time today.
Thank you, Kelly. Yeah, that's great. So just let you guys know the global BGC Argo float usually stop at the 1,000-meter isobate. So it's kind of the deeper ocean coverage. There's some new technology, I guess, is still in development for shallow water Argo. But at the moment, what I see is a lot of people, they see this, the coastal observing system, the kind of complementary to the BGC Argo global coverage. So I think this is kind of the synergies. I think it's great to have Kelly to talk about this. But can I have all the panels maybe sit in front of the, yeah, so then and we can open up the floor to ask questions, comments, concerns, suggestions.
I was in college, I had a table made of a lobster pot.
Miguel Santos from IPMA, Portugal. I have a comment about the BGC Argo, because BGC Argo is, I'm also involved in these programs. BGC Argo is developing a lot sensors to put in these floats, and I think, and they test a lot, make a lot of calibrations and comparisons between sensors, different types of sensors, and this could be a good link to development of our observing system on fishing boats, because they are already testing the sensors and so on. So I think it could be a very useful link to our system, to our coastal system.
Thank you. Anyone want to respond to that?
Just to say, so there used to be, I think I funded an ACT project periodically. I think it was called ACT. They would actually.
Correct, the Alliance for Coastal.
Yeah, Alliance for Coastal Technology used to actually stand up intercomparison projects. Line them up. So maybe something like that would be good.
Partnership with NOAA, and they've been doing it here. We've been funding them, and they do, their main goal is, you know, everybody's developed these gadgets, but if you don't calibrate them well, you don't test them well, they're not going to be in the operations. They're not going to put them in Argo floats or in buoys. They have to go. Sorry. Okay, they have. Okay. We use the same as NASA does, the TRL, the technology readiness level. And if they are not at the level where they can transition to operation, they will stay at R&D. And there are a lot of that in R&D. So.
Yes, and one thing they do is that they have these standards. So when you have a float, the sensors are approved by the Argo steering committee. So they are standards. So to belong to these sensors or the floats have to be with certain standards. So you cannot use the sensor you want or something like that. It should be approved by them. So it's a good thing that we have a standardization of this.
Cooper Van Branken, thank you all very much. Great to have the knowledgeable panel and discussing kind of from the other perspectives how we've been talking today. And one thing that kind of strikes, you know, coming from the other side and working with this data and everything like that, you know, these data, you know, at least on the physical side from fishing gears and everything like that, the profiling data, you know, it's going to be in the GTS pretty soon. The quality is very well documented, like side by side with the Pioneer array. You know, from my perspective, this is good to go. And you know, think about half of what operating a glider costs for 1 year. Well, you know, you can plaster the entire East Coast. So, you know, it seems to me, you know, what's the path forward beyond the OTT funding to kind of like thinking about ocean observation from a different paradigm. And then I think, you know, piggybacking on the demonstrated success of the physical monitoring, then we can start looping in this other biogeochemical components and, you know, building on that network.
Cooper, I didn't hear the question. Can you ask the question again?
You know, how can we, you know, from the federal level, how can we, you know, every scientist I talk to and every ocean data user is like thrilled with the data. It's like, oh, this is good, and yes, but then, you know, I talk to folks at the federal level, funding's flat. Jake's got moorings that need time series. I get that, but you know, the cost benefit of this and this approach is, you know, clearly orders of magnitude more cost effective. You know, so how do we move forward?
Yeah, I mean, that is a big nut we need to crack, Cooper. I think you kind of answered your own question in there. It's the cost benefit trade-off. We need to specify that more. I mean, this is why I kind of emphasize the need to build a use case, and I think taking that as far as we can into dollar value. You know, this is, I think, at the heart of this concept that Dr. Spinrad promotes of the new blue economy. It's really about centralizing the role of data, quantifying, even commodifying it, so that we can make that case. And I think until we can really start to translate any type of observing, but in this instance, BGC observing, into what that means for different industries in a very tangible way, it's going to be difficult to grow that pot. I mean, most of what people come to Syracuse for is real-time data for kind of day-to-day operational navigational decisions. That resonates, and it can be quantified. A lobsterman can tell me, if I check the nearest buoy and just discover that the waves are too big to go out, I've saved myself a couple $1,000s in fuel, bait, and crew costs that I might have spent only to turn around and come back. We need those kind of numbers that we can then take to Congress and say, look, this network of observing stations and models and products is going to support industries to the tune of X above and beyond what they would have been able to produce otherwise.
Can I say something? Can you hear me?
Yes.
I tried to raise my little hand on the screen. It's hard to hear. I guess you can't see my little screen. I just wanted to add that, look, this is not rocket science, actually. It's, I guess, ocean science. But the point is that we will always have more requirements than funds or resources in general. 20 years ago, almost, the Ocean Commission, when it came out with its landmark report, estimated non-federal needs in this area, namely what the regional associations implement, to be around $500 million a year. When Congress asked the federal government and the federal partners to estimate what a build out of the system would take, this was back in 2011, the number that came back for the non-federal side was $540 million a year. We're at like $41 million a year right now in 2022, 2023, right? So we're an order of magnitude at least less than the greatest estimates of a decade or two ago. What that means is that despite inflation, which makes it more difficult for us to manage the existing network, the increase in demands requires us to make prioritization decisions that aren't based always on logic or based on merit. They're based on what the biggest bang for the buck is, based on politics, based on economy, based on things that people care about today and now, not on basically what we might care about in 20, 50, or 100 years from now. And so we increasingly need your help to make the kinds of arguments Jake was talking about, to be able to advocate for these things, because we know they're important and you know they're important, but we're fighting against all kinds of competition, not just from other non-ocean science or environmental areas, but even within our own environmental science areas. And so, again, it just comes down to being able to make an argument that speaks to the needs of the current funding decision makers. And we think we can do that, but we need your help, because they like to listen to the community more than to me. They know that I'm convinced, right? But they need to know that you guys are convinced. And when we talk to Congress or anybody else, we need to be able to deliver to them, because they care about what you think.
Well, thank you, Gerhard and Jake. Really, that's the key. And I've been talking to a few of you, and I think one thing I realized after talking to for these 3 days now is that I would throw it on you. I would challenge a little bit this community to come up with a vision. That's maybe will be a key to move this forward, because we are talking not only about BGC, but we are talking about the whole fishing-based observations. And I think the way that Gerhard has said it is right. Use cases. What is for? What is your vision? What you want to do with this? Okay, collecting observation is great, but what is the end goal of it? Okay, I will throw it back to you, Cooper, because that's the key. I think we have to come up with that vision for the whole community, and that will speak to whatever that Gerhard is saying. When you go to Congress, you can tell them why you're doing this. I'll leave it at that.
So I just want to add two things. One is there was a mention of the daily cost for sail drone operation at $2,600 a day. I'll point out that our program does not put a nickel towards that at this time because it's cost prohibitive. And if we were to task out a sail drone at that cost, it wouldn't be for an annual operation. It might be for a targeted mission over a few weeks because that is a prohibitive cost. The other thing is the assumption that this is an order of magnitude less. I'd like to believe that. I hope it is. But honestly, the cheapest thing for me is an asset. That is not the cost of an observing program. So you're saying that multiple sensor package deployed in multiple ships is going to be less than a single high quality asset on a fixed mooring. I don't know. I'd like to believe that, but you know, I really would like to see, you know, the beans counted out because I don't. This seems like it would be targeting exactly the environment we want to characterize. So I'm excited from a scientific perspective, and because I believe we can make a business case for it much stronger. But arguing that it's going to be a lower cost really hasn't been demonstrated at this workshop just yet.
Yeah, Nick Lowell Insurance. I mean, I think we could debate that point right now because really good examples being Linus and Tracy's projects with dissolved oxygen sensors, where they have 25 plus sensors that they've been deploying for multi-month deployments with, you know, tiny budgets basically. You know, in Tracy's case, we do charge her an annual fee, but I mean, it's a couple $10,000 to $20,000 at most, and then she spends some time on it, but it's not her full-time job or anything. And we're getting 25 units out there measuring dissolved oxygen in a spot where people are really interested in what's going on. The same thing is true with Linus. So there's definitely, maybe we don't have a white paper out there showing it, but this is an affordable way to target environments where you really want to know what's going on. And I think that this can be replicated over and over, and it will be.
Nick, I think you brought up something really good here, and this kind of harkens back to what Jim had presented as the human capital needed for sustaining these projects. So you just cited some of the oxygen work, and I think, Linus, you can correct me if I'm wrong, but that's not a sustained project with people supporting that. And so anything that, say, our program or any of the other programs up at the panel here would need staff and all this other infrastructure to support sustaining those, like a fishery-based monitoring program. And that's what we're trying to get to, like Dwight had said, count those beans. And, you know, Alec, you'd mentioned that there might be a white paper coming out of that. I'd be very interested in getting down into that nitty-gritty to kind of price that out and being part of this white paper.
Thank you. We have online questions. Heather, go ahead.
Yeah, I have a comment here from Owen Nichols. Following up on a conversation I had with Alec in lunch yesterday, in addition to funding and support of monitoring programs, we should consider prioritizing funds held in reserve to support a rapid response to unusual events and anomalies, much like the way Glenn, CFRF, and the Squid Squad were able to get the FV Deerston on site quickly to survey around a salinity maximum intrusion. Fishing community observations are so important in this context, as they are often the ones who see events like the hypoxia in Cape Cod Bay first, and they are also much better positioned to collect data or get scientists out to collect data quickly and cost effectively relative to the time and money it takes to get a research vessel on site.
That's a great comment.
Superb comment, and building on that, I've spent the last 5 years working with autonomous vehicles, both air and marine. And to the point about the sail drones are essentially top of the line, VC-backed, DoD purchased platforms. There are much less expensive autonomous surface and subsurface vehicles that may be available to help that. But to the quick response point as well, autonomous air and surface marine and subsurface marine may be a component of that rapid response capability as well, and also providing long-term enduring multi-sensor platforms for a variety of deployments.
Thanks. And I wanted to add, you know, we do have these numbers. You know, there's a lot of numbers, you know. I think a good example, though, is New Zealand, where they've got over 200 vessels operating, and they've flipped the observation paradigm. They're data rich in the coastal waters. You know, looking at a track of the amount of data going into their operational model, it's being assimilated in real time, it's being used, and, you know, they used to have way more data out from the Argos, and now they've got way more data in close to shore. Like, that's incredibly powerful. Their budget for that sensor component, it's less than $1 million a year. You know, that's less than one buoy. They've completely changed the game doing that. We're starting to work with folks in Africa. They can't afford gliders, they can't afford buoys, they can't afford anything. They can afford our stuff, and we're mailing it out and like putting it on the boats right away.
That's a good point. It depends what kind of buoy we're talking about. There's plenty of buoys you can buy and operate for comfortably under $1 million. But your point, I still take your point. Probably true.
I don't think, I mean, the question is about who is cost effective here. You're not going to get rid of buoys. You're not going to get rid of vessels. You're not going. The point here is to bring all this together. Every observation is useful. Science need it. The operators need it. That's the point, is how to add to more coverage. You know, he's mentioning, Cooper mentioned the coastal areas. And you can tell, I mean, sometimes we don't have enough. I've been doing myself. I went, because I think Jake showed you yesterday at the bunket there, I mean, whatever we had there, showed you the ecosystem indicator, NOAA. And I took the dissolved oxygen as an indicator. I took care. I just, okay, well, let's go see what we have. And I download every data that you can imagine from the Word Atlas, everything, and I still cannot get that indicator. What it's telling you is that we have a gap on our observing system. And to complement all that is adding more observation. And not like this is cost, it's not about the cost. We can bring all this together. That's the important, that's the thing I want to make sure we can get all this.
And I'm not poo-pooing any of this. I'm excited about this, and I'm just saying, you know, we do need to work the costs out and like to see what they are. And I believe you if you say it's less cost effective, but I do got to see the numbers. But what I would say is I do think there is a good business case that could be made for this. And like Gerhard was saying, you know, that's the case we need to make. It's not the observing capability we're going to gain from it, which sells it to me, but I got to sell it to Congress. And Congress is going to want to see a business case for it. And so that's our challenge.
Yeah, hi. Well, in my fisheries, I have 6 boats tied to the dock 10 months of the year. And I've been branching out to try to get little leasing work here and there. Just to give you an example, we did 3 cruises here for a particular scientist in at Hui at $5,000 a day. Two-man crew, you know, mate and a captain. Where do you want to go? What do you want? $5,000. We're not going to get rich, but we got $1 more at the end of the day. You know, a little something's better. So there are cheaper alternatives. I know I worked for NOAA. I know what the rates are. I was getting my bennies on deck and all that. So I did it. It took us like 8 months to get registered with SAMS. 2 of the 6 boats. Fill this form out. Oh, you didn't dot here. Send it back. Just to give you an example. Hui, they came down. They inspected the boat, certified it. Boom. We have 2 boats certified with Hui. So they're you know, 2,500. I basically did it for twice that. Go where you want. Fuel. Good eating too, by the way.
Thank you.
So just to follow up a little bit about both the budget conversation and Nick's point about it being cost effective, I agree with both perspectives. I think that it is cost effective. I think that it is important to account for staff time. I have not done that, so you've given me a really good idea of maybe what I should do with our next step in terms of evaluating the DO fleet and how we've done things, the amount of time I've put in, I honestly, I don't know. I just did it. Other stuff definitely didn't get done, and I don't know how to quantify those trade-offs. You know, that might be something I might go back and sit down and have a good think about in terms of some sort of a white report or reporting out to, you know, what did it actually cost us on top of the, you know, the actual purchase of the equipment, the maintenance contract, that kind of stuff. And then if I can try to get then some input from the fleet members, and you know, maybe this is again going to be a thing moving forward because we were lucky enough not to have a hypoxic event in 21 and 22, so it gets hard to quantify an impact when there wasn't an impact. But to try to maybe think about what does that mean in terms of the day-to-day operations of the vessels that were in the affected area. So you guys have collectively given me a good idea of a next step that I can do with our sort of small targeted project that might help inform arguments to be made for bigger scale. So.
All right, thank you. I think we're at the time, so let's give another round of applause to the panel. And Jenny, you want to? Just a couple of thoughts. So in terms of next steps, so we are thinking about, especially the last discussion about the white paper. Okay. We're probably going to come up with a report, but that's probably not going to be, you know, talking about the cost of the network. But in the white paper we're talking about, we're probably going to touch something along that line. So, the, you know, the benefit of it obviously is there's a lot of benefits, right? And then the cost, we originally didn't think. I mean, I originally not. You know, as Dwight suggested, this is the kind of not the full picture of the cost. So I would really love people, if you're interested in the white paper, so come to us, that we can have a group, you know, draft the white paper, and the white paper can be peer reviewed. So this could be useful credit for people who participate. Okay. Yeah. But.
Thanks. I just wanted to make a comment on the white paper as well. And thinking about this, you know, one of the really useful things that just came out of this discussion, I think for me, was hearing about all these case studies for, you know, how we can quantify this. And I think for all of you who are here, who have run these observing programs, you know, in collaboration with fishing industry members, I really would encourage you to try to, you know, participate in this white paper because, you know, your experience and you know, exactly what was mentioned about, you know, the cost effective, actually calculating what those costs are, what the benefits are, you know, your use cases are going to be really important to this. So especially folks who have been participating in these programs, running these programs, and anybody who's interested in potentially running them in the future. So really everybody who's here today would really encourage you to reach out to us to participate in this.
So before I open up, just another thought for follow up the panel discussion. And I think Cooper alluded to this. So in terms of cost, my view is maybe the cost structure in this kind of observational program is very different than the traditional program. I mean, I think Tracy said that very well. It's like you know, because the benefit and the cost is to the level that you can absorb some of the that cost in your daily you know, operation jobs, that by itself is actually a little bit different operation your cost benefit. So I don't know exactly going to be, you know, on the larger scale what's going to look like, but just look at the Cape Cod Bay program. It's pretty cheap in terms of you know, the delivery. Data delivery and usage, and that's I mean, that's a good model, at least for that region. So I can open up the comments, questions.
This is quick, and it's because I forgot to mention it earlier. I just wanted to make the point that in terms of the staff time, the initial time with the Cape Cod Bay project was all upfront. So once we got through the initial lift of getting it off the ground, once we got through the aspects of getting the data processing that I talked about, all of that kind of stuff done, now we're at like the coasting phase. And so those staff time investments are going to go way down, I hope, in theory.
Maybe this is not a comment, it's a thanks. I'm very new to this community, and I think I've met and talked to everybody in this room today, plus a whole bunch of people no longer here. You all have been incredibly generous with your time, your observations, your experiences. The disagreements have been very friendly and productive, and it's a tremendous community, and thank you all very much.
Thank you. Yeah, I've really enjoyed listening to all the discussions. And I just wanted to circle back to that point about cost effectiveness and sustained budgets for, collective, collaborative ocean observing. I've talked about what we've been able to do on the West Coast with crab fishermen and biogeochemical. This research is all soft money. If we don't get any more grants, this entire partnership that we built over the last 3 years just kind of goes away. I'm really the only one working on this, and I spend most of my time working actually on the endurance array. And, there's no funding for full-time staff. So that's important to, it's very cost effective and it's very near and dear to me. So that's not really anything, just a comment.
Go ahead, Jim.
A little poem in contribution and appreciation of the fishermen here and those that collect data so far and into the future. They're out there almost every day with rules and rigs, uncertain pay, dodging whales, pleasure boaters, friggin' wind farms, goddamn quotas, dealing with us and our strawberry pies. Sometimes works, often dies. Price of fuel, observers, crew. Still, they survive, they make it through. So, as I look back, I do reflect. These captains do deserve respect. More than most, they want these waters for their sons and their daughters. More than most, they love the sea just as much as you and me. So let's get on board, form a team, let's sail together, sail a beam. Make a plan for decades hence. Chart a course that makes some sense. Survey the shelf, surface to floor. With shitloads of data like never before.
Heather?
I've got a question online. Would an ACT, Alliance for Coastal Technologies, like intercomparison, be a good next step to contemplate?
What people? I mean, I can start. Is this on? Hello? Oh, yeah, this is on. Yeah, so actually there was a question about the data quality I want to raise to the agency folks. What do you view of the data quality kind of requirement, coming out of from such a fleet? For example, oxygen, pH. What kind of quality do you expect, or do you think we should kind of shooting for at this stage at least, so that the intercomparison part is coming. It's coming based on the kind of the requirement we're shooting for. I mean, kind of data quality we're shooting for. Should we really shooting for something climate quality? If that's the climate quality, then I have to do bottle samples of this, and that's a cost. That's labor intensive. But what kind of the bar that you guys can maybe suggest, or then we can follow up then the data quality comparison, things like that, like involve ACT in this.
Right. So it's entirely dependent on the objective of the observing system, entirely. And I look at monitoring the environment from two perspectives. From an ocean acidification perspective, anyway, you could be looking at trying to quantify long-term, what we call secular change, right? Looking at multi-decadal changes. And in that case, that needs to be really climate quality, which is why we're not planning to stand down our long-term time series anytime soon. But the products that I envisioned for this, I'm hoping are going to be much more, near term, describing the dynamic ranges of something. And therefore, I would venture that what we call weather quality is probably a more realistic approach. And then you rely on the large-scale geochemical surveys that come in to really, anchor it down. But for something like this, I wouldn't be trying to be emulating, a map CO2 system in terms of precision. So I don't have an exact number for you, but the community needs to think about how the data is going to be applied. And so I wish there were modelers. How many modelers do we have in the room? Modelers? Oh, come on, Emily. Emily's going to tell us. What does it need to be? Give me a percentage. 0.00.
I mean, I would have to defer to my advisor, Samantha Sidlecki. I use the model data in like a biological application to do like modeling an individual sea scallop. That's what I'm working on right now. But I think for like this approach, if we're thinking of like event scale variability on a daily cycle or seasonal cycle, I think weather quality data is just fine for that.
I wanted to make a comment on this as well. So going back to Dwight's point about the use case and what you're, exactly what are we using these observing data for? Someone mentioned earlier on our panel that we really need to make a business argument as to why these data are useful, from an economic perspective. Someone brought up, marine CDR. Do we think that this type of data is going to be useful for quantifying carbon dioxide removal? Probably not. It's probably not measuring these parameters at a high enough precision, at least at this point in time. But I think there are a lot of other potential use cases for this from a business perspective and also, from a biological and scientific perspective. So again, I think, as part of that white paper discussion, we should maybe be thinking about, what are those use cases for such a network?
And actually, I would love to add one more question along that is we're user driven. So you guys, Fishers, you use water temperature all the time. So then there's obviously the quality of the water temperature measurement. Okay. So and then Dwight and all the carbon folks, ocean acidification, we're talking about the threshold of saturation state of calcium carbonate. Okay, there's line 1.5. We actually don't know whether it is 1.5 or not. So in real time, in real field condition. I guess the question also back to the fisher is that some of the parameter what kind of the data quality requirement or you feel is useful for you. So then we can build up that user-based case.
Right. Putting the equipment out and deploying it anywhere at any time is not the problem. Whether or not you're going to demand a lot of time from fishermen to do something while they're deploying it, analyzing. We know the science community is after all this information. Go for it. We don't care. We want to know either why we are catching our product, and if we aren't, what happened, where did they go? Now, experience might tell us where we're going to go because we've learned over years where to go, but not everybody has that. So deploying isn't a problem. Keeping it simple was one of the things. The cost only comes in if you're asking more than simply deploying something. We did the dissolved oxygen. It was kept at a minimum in Cape Cod Bay. Expense-wise, I think most of the expense fell upon your time, Tracy, and DMF's time and things like that. We were interested because it directly affected what we were trying to harvest, the lobster. So if there's a change in acidity, if there's a change in the dissolved oxygen or any of that, or in the case of currents moving things around, be it scallop spat or anything else, those are the things that we'd try to figure out ourselves while we're going out on the water. But we would like to know if the acidity, the dissolved oxygen, or the currents have had an effect that causes us to see less. So the community, a fishing community, is willing to go out and try to work, some of it, not all, not many, but trying to work with that. Part of the reason that it was done effectively and inexpensively in Cape Cod Bay was it directly affected us immediately. We wanted to know. Now we'd be worried if cost was going to minimize what we were looking at, because we still want to know it. It's not like, gee, it happened 2 years ago, it's not going to happen next summer or this coming year or 4 years from now. We want to know these things, and we want to keep going, and we're asking not what you interpret or any of that, but if you've got simple equipment and somebody is assured that can analyze it and let us know, that's critical for everything that we're doing.
Great, thank you.
And what's the ballpark value of the lobster fishery?
The ballpark value of the lobster fishery, you mean in the northwest, from Canada down? Just Maine. Don't talk about Maine. We're in that. Those guys went home. Well, you're in the hundreds of millions of dollars. You're shy of $1 billion. And it is critical on a lot of aspects. Yeah, Maine catches a few.
Maybe Heather?
Yeah, they're overrated.
I just have a comment online from Michaela Martinelli from the Institute of Marine Biological Resources and Biotechnologies in Italy. Says, keep an eye on what is happening in Europe these days in the Nautilus Horizon 2020 project. We are using protocols developed in previous EU projects to test new dissolved oxygen and fluorescence sensors designed for fishing gear. And she provides a website and a preprint link here if anybody's interested.
Thanks. Great, go ahead.
Did I press it? Okay. I just want to follow up on this gentleman's comment on that and just reiterate that the co-production of science that I was talking about is really valuable to us as a program. And this is where I was saying before, I'm very comfortable with acquiring biogeochemical data, but it's that other side of the equation, you know, that's going to help, like Haley, understand biological responses, not just in the tank, but in the field. So we really have to have we really would like to think about things that we want you to report us. So I would argue, like, I'd want it to be as simple as possible for you. I want no lift on your part. It should be zero cost to you. The only thing that the only effort I'd want from you is to take the effort to actually report us the things that aren't being picked up by the sensor. The sensor's easy. But like if you went there and you're like, hey, there's no scallops here this year, that gives us a clue to actually be like, okay, we need to interrogate the environmental conditions of that. And then that helps us develop real thresholds validated in the field that we can then come back to you and be like, all right, everybody, these are the conditions you're looking for, right? So that co-production of science, I think, is huge.
So one last question to this group to prompt a little bit of discussion before we wrap up for the day. How can we stay connected as a group? How do we, keep this engagement going? There's been some really phenomenal conversations throughout this entire workshop that I think really we just want to keep it moving and keep this momentum going forward. Do you all have any thoughts or recommendations on how we can stay connected?
I was intrigued with Heather's concept to know a little bit more about her concept of a kind of a coastal interactive organization.
I'm not sure what that's, can you give me a little more? Are you thinking of when I gave my intro
I think we
remarks?
were talking about next steps.
Yeah.
And you asked how the group as a group felt about some kind of a organization where we can kind of cooperate and collaborate. That's how I understood it.
So I think there are a lot of ways to do this. We've done this for various disciplines of oceanography, ocean science, and related disciplines for several years now. A lot of times we'll have a large community workshop like this that brings together a lot of different practitioners, and it will lead to maybe a targeted working group if that's what's needed to tackle a couple of really specific problems. It might lead to tutorials or training activities to get everybody on board with accessing data products or developing data products that are useful. It might lead to developing a common set of best practices that we might need for these data sets. But at the end of the day, you have started to build a community here. And I really encourage you to, we have an email list, and we have a collection of materials from this workshop as a starting point. It's a kernel, it's a seed, and let's follow up on that and keep, I'm happy to keep supporting you in any way that I can to keep you talking to each other. If there are products that come out of this workshop that might lead to another activity down the line, our program, the Ocean Carbon and Biogeochemistry program, with support from NSF and NASA, put out a solicitation every year for community activity proposals. And that's where this came from. And it's a very grassroots, bottom-up process. So it's very much driven by what the community wants and what the community needs. And so that's how so many things have been built in OCB, and a lot of activities have ended up becoming a progression of multiple activities that have led to much bigger things. So it's a matter of having a core group of champions, and I think that's what you all are. And so, right now we have an email list and a collection of really enthusiastic people, and however we can build on that, I'm happy to guide you in finding what the next step is. And, I think this idea of a white paper to help inform our agency partners about what's needed and where to prioritize investments is a critical next step. And I really hope everybody in this room will contribute to that, because if we've learned nothing else here in our time together, there's so much knowledge in this room, and it's all needed to figure out the next step.
Thank you. My main concern was, we've come together and we've generated a lot of enthusiasm and everything, and I hate to see it just end there. Everybody goes home and gets involved in their own little circle. This is Hassan's idea that there needs to be a vision and steps. I see something that we all need is for all of these programs, we need funding. We're just chronically under-observed and underfunded, and so there needs to be a vision that can be communicated and a means of providing the fuel for us to go forward.
Sorry, Jim, can I have Gerhard online? he has some comments, and then maybe Cooper and then Jim.
Yeah, thank you.
Go
I
ahead.
just wanted to say that the comments just that were made, I'm sorry, I couldn't see who that was, but I thought they were really good comments about, well, one, trying to create perhaps an appropriate venue to keep this going, just because I agree, there's oftentimes we come together, there's a lot of goodwill, a lot of good ideas, and then we go back to our day-to-day and there's no mechanism to keep us going forward. And all these things take people, they take time, they take energy, and no one's sitting on on their hands here with nothing to do, looking for something else. So I don't know, I don't want to necessarily volunteer anyone, but I would say we could explore some of the existing mechanisms, like maybe one or both of the cans or somewhere else that has some capacity, has an overlap, and could take on a discussion until such time that it's deemed that it has legs of its own, or is going towards specific projects in a different direction. I like to use and leverage existing stuff just because you've already got people, and if there's a joint interest, it can lead and snowball into some other discussions and benefits for everyone. So I can't speak for Jake, and I won't throw Mary or Avalon from Maycan under the bus, but I think maybe explore some. I mean, again, if somebody wants to step up and do it right away, by all means, awesome. But if it would make it easier, perhaps we could explore some of our existing partnerships and leverage those until such time as it either goes on its own or doesn't. Thanks.
Thanks. Cooper?
Yep, thanks. Cooper here. Thank you all for, a wonderful 3 days, and I'm thrilled to hear that, everybody wants to keep going and is excited about this across the spectrum. But I want to remind everybody that there are a lot of people not in this room. The biggest programs doing this, none of those people are here. And there's a lot of progress, like Michaela mentioned, happening over in Europe with the Nexus project. So kind of going back to, I introduced this a little bit, the FE-ON, Fishing Vessel Ocean Observing Network. There is this group of us coming together to steer this. So, involvement from this group, I think that would be fantastic, and everybody's really thrilled. And there have been a lot of people tuning in online who haven't been here. So that's great. And then my final thought is like, okay, there's a lot of people in this room, and Jim Moore represents over 1,000 trawlers in Alaska. Well, what happens if there goes 1,000 letters from those trawlers to Alaska congressional representatives and things like that? I think the combination of the folks in this room, we could influence a lot of kind of the stakeholder feedback and stuff like that. So I'd be interested in, talking about that and really showing that there's a lot of us here, and we care about monitoring the ocean from a lot of different perspectives.
Thanks. Jim?
I think if we're going to do this big scale with many groups coming together in the Northeast, we talked about needing people. One critical part of that is a set of dockside technicians. I think we need somebody stationed at the dock in Gloucester and New Bedford and Point Judith and Cape May, permanently funded by the whole group to maintain things.
Thanks.
One of the things that will come out of all of this, I'm sure, is a white paper, which is absolutely meaningless to 90% of us. I worked on a white paper a year ago, 2 days. All of that dealt with a good friend, the northern right whale. I have absolutely no idea what the hell happened. It went to Washington, they read it, and they didn't pay attention to it. When you have a group of people that get together, yeah, it's really nice to know that that the Mediterranean is doing things with the commercial fisheries, and I've met with people from all over there too, and the same thing. We meet, we talk about it, we get excited, we all jump up and down, and we want to go do something, and then we go our happy ways. If you wanted to get the group back together and do it, you have to. But then it boils down to what you were already talking about, the funding. So OCB hosted this, good food, paid for it all and everything else. Well, maybe NASA will do the next one here, and NSF or anybody else would do it to host it. You could keep it going to hope it will continue and to hope that things will keep going. Your community corresponds back and forth. We go out fishing, and we're not going to spend that time looking at all of those things that you're trying to do. Give us a project, we'll take care of it. Give us feedback on it, again, we'll look at it and we'll try to give you more information. That's the tough thing, yes. That's the hardest to share it from the commercial fishing. But I think it always works out like that. Everybody gets excited about it, and then we all go about our own business. And yours is collecting data. Yeah, maybe you're going to get it from me or a few others, and you're happy with the data you're getting. And you say, we need more. Well, we got to keep doing it. And the only way you do it, basically being a dinosaur, I'm not a big fan of Zoom. And I don't think I think you get more accomplished by this because we can argue across the tables than anything else. And obviously it works a lot better when you have the in-person. We can keep our 6-foot distance. We can wear a mask, we could do it, but at least we can point at somebody and say, I don't agree with you, rather than raise my hand or go mute or do whatever. Thank you.
Thanks. Jake first.
Yeah, thanks, Alec. Just to Gerhard's earlier comment, I'm happy to have him speak for me. I think NECAN is a very logical, convening venue. I haven't looked actually at the membership of the industry work group for a while, but my sense is it's biased toward shellfish growers, and maybe more wild harvesters of different stripes would be warranted. I think, I have a feeling the lobsters consider publication lists in deciding which traps to walk into or not. So I wouldn't be too dismissive of the value of a white paper. But I actually think, the white papers are really valuable for kind of capturing all the rich content that comes out of a meeting like this and reminding ourselves a year later exactly what we talked about and not reinventing the wheel. But we probably need some communication tools that I'm not sure we have quite the right expertise in the room for. It's certainly not nerds like me, and it's certainly not fishermen that are best suited to figure out how do we really move Congress? How do we really convince those who can make funding decisions? I think that boils down more to kind of nicely graphically designed, pithy, punchy 2-pagers that talk about needs, talk about benefits, pepper in some nice photos and quotes from fishermen. Like, there's a lot in this meeting, I think, that could be distilled. It will leave a lot of texture on the cutting room floor, of course, and that's where the recordings and the white papers are still necessary. But, keeping the conversation going is one thing. Getting new things to happen is another. And that means finding ways to really concisely take the nuggets, the most important nuggets from a meeting like this, and getting them out to the people who can make decisions that most of us can't.
George?
I think, keeping the conversation going is critical. And to that point, we're going to be hosting a symposium at the Maine Fishermen's Forum in March. So that'll be more targeted towards the industry and trying to drum up interest from them and get feedback from them on the existing systems. Similar to the first day here, just sort of explaining, existing technologies, what's available, and asking for, how can we make this more useful to you? But throw a plug out there for that.
Thank you. I just reminded, there are a list of other fishery-based forum or meetings on the board. So I think those are the very good comments from George. But there's a series of those. So people are interested, can all participate. I'm interested. I'm probably going to pick one or two if I have time to join.
Yeah, so I just wanted to follow up on the utility of white papers. First off, I don't want any fishermen spending any time writing a white paper, just to be clear. That will probably fall to a lot of the academics in the audience. But just to give you a peek behind the curtains of how this works, in order to secure resources from Congress, I mentioned in my talk, and there's a reason for it, that Congress has called upon NOAA and our program to work through the coastal acidification networks to acquire a report of prioritization, a monitoring prioritization plan. So we're going to be looking for, ideas and concept needs in that document. So a white paper would provide a nice condensed resource by which we could be clipping material and putting it into this report and sending it to Congress. So this is when we sit down in the audience with staffers and they say, oh, we're getting all these, fishermen up in wherever, and they're asking for what are you doing to work in closer connection with these folks? And we can say, well, we just so happen to have this idea, let me pull this out of my hat, of a fishery-based observing system that'll get the benthic system. That's when that actually happens. Other areas where it happens is we will be advancing things within our own agency that go up, and then the agency moves to the Department of Commerce, and then that goes up to Congress. So that white paper does go places, and sometimes it takes a very long time to get there. So if you did it last year and you haven't heard anything back, it's probably for sure. And there are other political winds that lean against it. But that's why I use that as I use these things as ammunition in my job. So that's why I look for these things.
I got to clear myself. I'm not opposed to the white paper. I'm not, that is not it. Basically, what it boils down to is, right now, because of our situation, and I can only relate right now to the last white paper, which was on the whales. And our biggest bite is not whether or not NOAA or anybody else can send to Congress this information. Great, we want to hear that, we want it to go. That, I understand what the white paper does. We are browbeating our legislators. They're the ones, and we have them. Of course, we have our legislators on our side, all of our senators in New England, all of our House. They got to sell, and even Alaska and Oregon and California, a lot of those same things, they're all on board. They have to convince the middle U.S. senators, that the black-footed ferret is important as well as the north. So we're facing all of that. Nothing against submitting the scientific approach to the white paper. It's one of those things that's out of our realm.
All right. Hassan or Dave?
You go first. Thank you, everyone. Thank you very much. I want to thank you everyone for having us here. I'm really pleased with everyone, and I have to leave. Unfortunately, I have to catch my flight. So thank you very much. That's all I want to say, and we'll see you again another time. Thank you.
Industry hat on. White papers are important for us as well. We are applying for, and we've applied for DoD funding. We're applying for NSF funding. The NSF funding is to help support the things I've been talking with Cooper and others about in terms of getting data from the sensors to the people who need it. It's not actually generating revenue for my firm or in any way producing profit for us. It's creating enough funding for us to help contribute to the community. Having our names on a white paper that's associated with exactly this topic is very important for demonstrating to the people reviewing those funding proposals that not only do we know what we're talking about technically in our one narrow area, but that we're doing what's called community discovery or customer discovery in terms of making sure that we are working on solving a problem that actually needs to be solved. So that white paper is of deep importance to us as well as to academics, and ultimately it benefits, we hope, the fishing community as well.
Great. Maybe a last comment from Miguel.
also to thank you all to receive me here. And of course, white papers is important for some of us, but we have to go further for all of us. And usually we can do, or in certain kind of these workshops or things, the final thing, we make a declaration signed by all the people that saying this was the conclusions of this workshop, and this is very important for the community, etc., etc., and can send, I don't know, in your case, politics in your case, but can send for the right people to see that was a meeting that was involved with scientists, fishermen, the community, and they have a common issue and make that declarations that this is what we want to make in common, and it will be good for society or something like that.
Thank you. That's wonderful. So I think for the time, we're going to conclude. So we're going to have a organizing committee meeting after the lunch. So we're going to decide some next steps, white papers and the report and others. And one thing we can definitely discuss how we get everyone involved more efficiently. And then we have everyone's email. Then so we start from there. So probably, either it's go through a MECAN, NECAN kind of centralized a forum or some sort. We can discuss that. But I welcome comments, suggestions to get everyone engaged, either white paper or other means of communication. I actually envision this should be a kind of continuous meeting. This is the start of maybe a series of meetings down the road. This is just beginning. Just plug in. There's, I think, Miguel sent out the email to everyone. There is ASLO fishery-based observational session. And that, have a lot of partners from Europe and maybe in the New Zealand group that is going to show up. I'm going to try to be there as well. So this is a larger international effort. I think this is a pretty good way to push forward. But in the United States, I think the white paper probably going to focus on very much, try to persuade our Congress to do something. That a little bit different focus, right? So, but I believe Cooper has a white paper in print, I guess, but that's like a global thing, right? So I would like to thank you everyone for coming, and maybe we should give a last round of applause to OCB folks. Heather, May, and Mary is not here. They did a fantastic job and feed us well. And then we have wonderful menu here to discuss what is important to each of us. And thank you. And again, I think we should give us own a round of applause, So this is a wonderful experience. I mean, this is kind of the first type of workshop I've been. So I think we should applaud to all of us as well. With that, we'll adjourn and then safe trip back and keep us posted. Thank you.